that, we have cleaned out the pipettes so that we don't have any excess like solutions from previous labs. To do so, we're going to take some water. We're going to, I like to do it this way first, pipette it in. Take it on around it. We use this solution here, which completely cleans it out with anything. So before we start the next experiment, we want to make sure that we use the 20% stock solution to make sure that any excess water inside the pipette isn't water, it's the 20% stock solution. And if we do this, we shouldn't have anything that messes up the experiment and like causes any sort of possible errors. I'm going to use the more pipette to pipette a certain amount of the sugar solution into the 25 milliliter volumetric flask. And so I'm just going to squeeze the bowl, put it on, put it in there, and then just make sure to not let it go up into the bowl. I just want to like put it really close here. So then I have to read it by looking at the bottom of the meniscus.
It is formed when the water molecules touching the glass also want to bond to the other water molecules because of cohesion, and so it forms a circular type dent at the top of the surface.
You also have to record the volume of the solution like to one more decimal place, and that's not shown like on the meniscus. So since it's in the 10th place, I would have to record it to the 100th. And so I would probably say it's about like probably like 2.07 milliliters, and then I would just record that as the initial volume. I'll just dispense however much into the volumetric flask. And then when I'm done putting it into the volumetric flask, I'll record the final volume, and then I would just record that as 6.1 to 6.29 as the final volume, and then I can just go ahead
and put this back in. That was that part.
So now that we have the 20% stock solution in there, we're just going to fill it up the rest of the way with water. Concentration, we're going to have to employ the formula C1V1 equals C2V2, where C1 is equal to 20%, which is the initial stock solution, and V1 is equal to V final minus the V initial, and that is equal to 4.22. Our V2 will always be 25 milliliters. And to obtain our C2, we're going to have to use the actual formula. We can put this into the calculator with 0.2 times 4.22, 0.844, and then we'll divide that by 25 to get 3.37 as our final percent for C2. At the end of the lab, we clean the tabletop.